impressive, I don't know what is. The fundamental theorem of algebra. This is it. No, I did not come up. So what they're talking about is in the complex number system, if you are dealing with an x squared graph, quadratic, you will find 2 zeros. It might not be real, but you'll find 2 of them. You go to a cubic, you'll find 3. You go to a 4th degree polynomial, you'll find 4. So basically, whatever the degree is, that's how many zeros are in the problem. Real or complex. So that fundamental theorem is what that is. So, from now on, when you run into solve this, you're going to find all of them. There'll be 3 zeros. Now, you know with S-shaped curves, right, when you talk about left-hand, right-hand behavior, S-shaped curves touch the x-axis how many times?
2.
Could be once, could be twice, or could be 3, but it's going to touch at least once, right? The S-shaped curve, because it goes up and down in one direction or the other. So there'll be at least 1 real, maybe 3 real, but it could be 1 real and 2 complex, but at least you're going to find 3 zeros. So what you want to do on these, x minus 7. X cubed, is that it right there? No, I didn't call it. Y equal. What was it? X cubed plus 6x minus 7. Like that? All right. There's my S-shaped curve. It looks like it hit at 1. One, 0, 6, negative 7. It looked like it hit at 1. There's no x squared, right? So you got to put the 0 in there.
Why is
Right.
it 1?
Huh?
Yeah, why is there 1 on?
Why is there 1 here?
Yeah.
Looked like it hit 1 on the graph.
Oh.
Like 1 makes it 0. We're testing. So when this 1 drops straight through, 1 times 1 is 1, 0 and 1 is 1, 1 times 1 is 1, 6 and 1 is 7, 1 times 7 is 7, remainder of 0. So my solution right away, I know that 1 is one of the solutions. Now looking at the graph, it didn't look like it was twisting and coming back down anywhere, so what I have left is x squared plus x plus 7. Most likely that's not going to factor, right? So let's go to the quadratic formula. My b is a 1, so it's negative 1 plus or minus b squared minus 4ac all over 2a. So your a is positive 1, your b is positive 1, and your c is positive 7. So when you plug all this in, negative 1 plus or minus the square root. Do not type the square root into your calculator. Get the number first. So do the 1 squared minus 4ac. So I end up with 1 minus 28, which is negative 27, all over 2. What do I have to do with that negative 27? Because before the other day, we stopped. We said no more solutions and quit. Friday, we said what? Bring out the I. And I'm going to break it down into 9 times 3. Huh? Say that again? The negative 27? Remember, anytime now the negative's under there, we take the, basically we're taking the square root of negative 1 and bringing an I out to the front. So now we know it's complex or imaginary number. Which one can you take the square root of, 9 or 3? So now you have negative 1 plus or minus 3i root 3 all over 2. And we're done. That's as far as we can simplify it. But some of you might write it -1/2 plus 3 root 3 over 2I and -1/2 minus 3 root 3 over 2. I. Those would be the 3 zeros. Yeah, you can certainly just, because I said this was simplified.
Yeah.
Yeah, if you just want to bring it down and leave it in that form, I am definitely okay with it.
Since it's not
But-
variable.
Just to match the fundamental theorem of algebra, I'm showing that there are actually 3 solutions there. Yep. Find all the real zeros. This is a 4th degree polynomial, so how many should we find? We should find 4 zeros. Now, what you have to understand about a U-shaped graph. A U-shaped graph, let's see, it could look like that, right? It could look like that, or maybe it looks like that. I guess I should extend this. So it is possible that a U-shaped graph is shifted up, like it's opening up and it's above the x-axis so it never touches, right? So in this case, how many complex zeros will you find?
1. 4.
4. Remember, how many zeros do we have to find? We have to find 4, right? You have to find 4 zeros. That's what the fundamental theorem of algebra says you'll find 4. Now, if you remember, the other day we talked about complex conjugates, right? Complex numbers always appear as a conjugate pair. So if it doesn't touch the x-axis, you'll have 2 pairs, or a total of 4 zeros. What's this one doing? This is the day the sub was here. I call that a bounce, right?
Butt.
What?
Big butt. Big power.
Big power, big butt. That's all I
Joke.
remember.
Big power.
It was something else.
So we didn't learn much that day.
This-
I'm not gonna lie.
This, when a graph comes down and touches and it looks like, bounces off, it's not crossing underneath at all. It just hits and leaves again. That's a bounce, and that's called a double root. So it is possible that the number appears twice, the same numbers twice, and then it doesn't touch again, so you can have a complex. So here you'd have 2 reals, 2 complex, and then this one would have 4 reals. So that's a possibility in this problem. So could somebody quickly graph that on their calculator for us? You got it? Does it look like there are any nice numbers?
1, 3,
3.
Alright, so
3.
I have 1, -3, no x squared, so put the 0 in, 1 and -3. And I'm hearing that it looks like it hit the graph at 3. So you could go to your graphing calculator, type it in, and look at the picture.
Yeah.
So 3. So if the 1 drops through, 3 times 1 is 3, -3 and 3 is 0. 3 times 0 is 0, 0 and 0 is 0, 3 times 0 is 0, 1, 3 times 1 is 3, and it worked. So right away I know 3 is a solution. What was the other number? -1. So let's try that. So if the 1 drops through, this is going to be kind of boring, but 1, so -1 and 1 is -1, 0, -1, -1. -1 times -1 is 1, 0, 1 is 1, -1 times 1 is -1. It worked. So according to the graph, what's that? Yeah. According to the graph, then those, it looked like it hit, and we're proving by synthetic division that they actually worked. And then we have x squared minus x plus 1. So we're going to do the quadratic formula. So the key for you guys is to get to that level where at least you can get to the quadratic formula. So x equals negative, my b value is already negative, so I'm gonna write it down like this, negative of a negative 1, plus or minus b squared minus 4ac. A and c are both positive 1, all over 2a. So that's the setup of your quadratic formula. So I have a 1 there, plus or minus. Under your radical, you're going to get 1 minus 4, right? Be careful when you square the negative 1, that's positive. So 1 minus 4, which would give me negative 3 all over 2. Bring the I out. So now I have a 1 sitting up top. I have a 1i sitting over there all over 2. So 1, 1, and 2, they don't have any common factors. So we're good. That's a good answer. You can just write that down there. Because this is a fundamental theorem of algebra, I always write it 1/2 plus root 3 over 2, oops, I forgot my plus, and then put the I behind it, and then 1/2 minus root 3 over 2i. So that's how I'm going to write it to show you that we did indeed find 4 different answers. You can just bring the whole green blob down there and write it.